All right, welcome back everyone. This is Noah again, and in this video we're going to go through the solutions for finding the x-intercepts of the parabolas for a quadratic function using the quadratic formula. So we've got some examples here. The first one is f of x equals x squared plus 3x plus 2, and we want to start, where'd it go? Don't mind my Damian Lillard background, big fan. First, we want to start by setting this equal to 0. 0 equals x squared plus 3x plus 2. We'll identify that a equals 1, b equals 3, and c equals 2. I'll real quick rewrite the quadratic formula. X equals big long fraction bar negative b plus or minus the square root of b squared minus 4ac, close the square root, and then in the denominator of the big fraction we have 2 times a. So let's plug these values in. For this problem we have x equals big long fraction negative b is 3, so minus 3, plus or minus the square root of b squared is 3 squared, minus 4 times a is 1 times c is 2. Close up that square root, and then in the bottom we'll have 2 times a is 1, so 2 times 1, and we'll begin to simplify this. Bring down another long fraction bar, we'll have negative 3 plus or minus the square root of 3 squared is 9, minus 4 times 1 times 2 is 8, so 9 minus 8 inside the square root, and then on the bottom of the fraction we'll just have a 2. Right, this will then simplify on top to be negative 3 plus or minus. 9 minus 8 is 1, so we'll have the square root of 1, which is 1, and then the denominator is still the 2. So we'll break this up now. We have x equals negative 3 plus 1 all over 2, which simplifies to negative 3 plus 1 is negative 2 over 2 equals negative 1. Or x equals negative 3 minus 1 all over 2. This simplifies to negative 4 on top over 2 and reduce that to negative 2. So the x-intercepts we can state are negative 1, 0 and negative 2, 0. All right, on to the next one. We have g of x equals negative 3x squared plus 13x minus 4. We'll set this to 0 to find our x-intercepts. 0 equals negative 3x squared plus 13x minus 4. A equals negative 3, b equals 13, c equals negative 4. So the quadratic formula is x equals big long fraction negative b plus or minus the square root of b squared minus 4ac, close the square root, all over 2a. So we'll plug our a, b, and c in to get x equals big long fraction negative b will give us a minus 13 plus or minus the square root of b squared is 13 squared minus 4 times a is negative 3 times c is negative 4. Close the square root, extend our fraction line all the way under everything, all over 2 times a is negative 3. And we'll start simplifying now. So on top we'll have negative 13 plus or minus the square root of 13 squared is 169. And we have 3 negatives here. Minus 4 times negative 3 times negative 4 will be a minus. 4 times 3 is 12. 4 times 3 times 4 now. So 4 times 3 is 12. We still need to multiply by 4. 12 times 4 is 48. So we'll have 169 minus 48 inside the square root on top. And then this is going to be all over negative 6 when we multiply the 2 and negative 3 on the bottom. Continue simplifying. We'll have negative 13 plus or minus the square root of 169 minus 48. 169 minus 40 would be 129. Minus 8 is 121. This isn't so bad. The square root of 121 is 11. So this is going to be x equals negative 13 plus 11 all over negative 6, or x equals negative 13 minus 11 all over 6. Negative 13 plus 11 is going to be a negative 2 over negative 6, which reduces to a 1/3. Or x equals negative 13 minus 11 over 6 will simplify to negative 24 over 6. Oh, negative 6 there. The negatives cancel. 24 divided by 6 is positive 4. So the x-intercepts for this problem are 1/3, 0, and 4, 0. All right, one more example here. Part C, we have h of x equals 2x squared plus 4x plus 1. Set it to 0 to solve for x. 0 equals 2x squared plus 4x plus 1. A equals 2, b equals 4, c equals 1. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We'll plug our values in now. So x is going to equal negative 4 plus or minus the square root of 4 squared minus 4 times 2 times 1. And this is going to be all over 2 times 2. All right, we'll start simplifying. We'll get negative 4 plus or minus the square root of 16 minus 8 on top. And this is going to be all over 4. We start simplifying now. On top, we'll have negative 4 plus or minus the square root of 8 all over 4. And we can't do a whole lot with this. The square root of 8 doesn't have a nice whole number answer. However, I can note that the square root of 8 equals the square root of 4 times 2. This is the square root of 4 times the square root of 2. The square root of 4 is 2, so we'll get that this is 2 square root of 2. So I can simplify this a little bit. It's negative 4 plus or minus 2 square root of 2 all over 4. And then we can actually simplify this a little bit more here. So I'm going to say that this equals negative 4 over 4 plus or minus 2 square root of 2 over 4. What I've done is I've broken it up into two fractions. The denominators are the same. Like if I had 1/3 plus 5/3, right? They have a common denominator, so this would be 1 plus 5 all over 3. But we could break this up and go backwards with this, yes? So that's what I'm doing here. I'm breaking this up as two fractions with the same denominator. And this allows me to reduce each of these fractions individually. So negative 4 over 4 will be a negative 1, and we'll have a plus or minus. The 2 and the 4 in the next fraction, the second fraction is 2 root 2 over 4. That reduces to a 1 root 2 over 2. So I'll just have square root of 2 over 2 here. So we get negative 1 plus or minus the square root of 2 over 2. So the two x values are x equals negative 1 plus the square root of 2 over 2, or x equals negative 1 minus the square root of 2 over 2. All right, with this, we can now state our x-intercepts with exact values. The x-intercepts are negative 1 plus the square root of 2 over 2, 0, and negative 1 minus the square root of 2 over 2, 0. We'll go ahead and get some approximations of these values here so that we would be able to graph them if that was our goal, and it will be in the future here. So let's see, let's just delete these previous ones. All we want is -1 plus a fraction, and on top we'll have the square root of 2 on the bottom of a 2. And so we get that first one is approximately -0.29. The second one now we can take and actually duplicate this, and we can change the plus to a minus. Speeds things up a little bit. We get approximately -1.71. Making sure to round that 0 up to a 1. It's -1.707, and that 7 will round the 0 up to a 1 when we use 2 decimal places. All right, that is it for this problem and for the solutions to the Now You Try problems. Thank you so much for watching, everyone, and we will see you soon. Take care.